right, guys, welcome to our very first real lesson in statistics. Our learning target for today is that you guys are going to be able to identify quantitative and categorical data. And then we're also today going to collect data and make conjectures. The only thing that we have on the agenda is an activity, so that means you don't have any formal homework, but you are to take notes on this video and the activity, and then submit them when we're done. Okay, so let's get started. So this is lesson 1-1. This video might seem like it goes a little bit fast. Just know to pause and write things down and then press play, and then you can hear me explain them. So right now I would recommend pausing it, taking these notes, because you do need to take a picture of these and submit them for your work for today, which is what you're going to do at every single video. So every video that you play for statistics, you're going to take formal notes on them and then take a picture and then submit them. Okay, well, just about everyone, most of them. I'll let you know in the videos. Okay, I'll get started, sorry. All right, so we have two really big important ideas. I did an LT, like a learning target. I don't really know what I want to call them because they're a little bit different. But anyways, so I want you to know that individuals are a person or they're things that are described in that data set, which is different than a variable. A variable is could be anything that that is attached to the individuals. So, for instance, categorical or quantitative. So think of categories, right? Categories is like a label, which is written below. And then quantitative is a number that makes sense, like to find the average. And so you want to look to see, can you label it, or is it something that is more based on numbers? Okay, and then like the second little learning target here is a frequency table. And a frequency table shows the counts, like how frequent, how many times did you press pause during this video? 4 times, 5 times, so it counts. And then a relative frequency table, it shows the percents. So out of 100, 5% would be a really bad example I just gave myself. Sorry about that. But we're gonna see more in what this looks like. All right, so hopefully you've had time to write those down, and those are the two big areas that we're going to discuss further for today. All right, so here is an activity. It's the 1 in 6 activity, and it's a Pepsi company. They decided to run a promotion that 1 in 6 wins. So 20-ounce bottles of soda. Some of the caps said try again, and some of them said that you're a winner. So a certain statistics class, they were wondering if this claim was true. Is it really 1 in 6? So to find out, all 30 students within that statistics class, they went to the store and they bought a 20-ounce Pepsi product. So out of all of those 30 students, 2 of them were winners. So does the results give convincing evidence that the company's 1 in 6 is accurate? So let's kind of look at that for a real brief second. Is 1 in 6. So 1 in 6 is what Pepsi is claiming is the winner. So 1 in 6 is actually going to be 0.16 or 17%. Okay, so 17% of the time that you buy a 20-ounce Pepsi, that you're going to be a winner. This is what they claim. So the actual statistics class, they got 2 out of 30, 2 winners out of 30 students. And so that is going to give us 0.06 or about 7%. So when they ran the study, only 7%. And Pepsi is claiming that it is 17%. So we're going to perform this simulation. Let's see what happens. All right. So what I want you to do is I want you to go to freeonlinedice.com. And once you're there, you're going to pick a 6-sided die, and then you're going to roll it 30 times, okay? And once you roll it 30 times, I want you to write down what your results are. Basically, you're simulating going in and seeing, picking it 1 out of 6 is the winner. Now, if your dice is a 1, 2, 3, 4, 5, it's a loser. If it's a 6, it's a winner. So you're only marking down how many 6s you get, and that represents the Pepsi winner, I guess. All right. And then you're going to plot that down on a dot plot, which we talked about in the last video. And it says to repeat steps 1 and 2, and then how many won the prize this time. So it's really important, just one time, just 30, one round, 30. Sometimes it doesn't give us enough information. We need to do this more. So I recommend doing it 3 different times and seeing what happens. Okay, so pause this video, go there and do it. Okay, so in a normal class, we would all have like little stickers, and I would have a big board up, and then you would kind of place your data, which I can't do that online, and I can't even do that in class, to be honest with you. So to show you what this potentially would look like, don't do that. 1 second. There we go. I'm going to move it over. So this is basically what it would look like. Each dot represents a person and how many they got number 6 on the dice when they rolled it. So if you take, for instance, if you take a look at this 2 right here, right? This 2, I had 3 people, right, in the class. 3 people in the class got 2 of the winners out of 30. All right, and so it goes on. One person got 10, they rolled 10 out of 30. They got 10 6s. Feels pretty rare to me. And so, yeah, this is what it looks like. Okay, cool. All right, so I'm gonna move on. So what percent of the time did this statistics class get 2 or fewer prizes just by chance? 2 or fewer prizes. Well, they did 2 out of 30, right? Because back switching over, you'll notice that only 2 of them out of 30. So 2 out of 30, we'll write that down. 2 out of 30 just by chance. Now, how many did our class do? So if you take a look, we had 3 actually, right? We had 3 got the 2. So I'm going to go over here, and our class did 3 out of the 30. So our simulation was 10%, right? So if it was 10% of the time, we got a winner. But Pepsi is claiming 1 in 6, which is about 17%. So here is your best answer. You're coming up with a decision based on the data that you've conducted, which I don't even know, like, because unless you email it to me right now, before you make your decision. Does it seem plausible that the company is telling the truth? That the class just got unlucky? You know, is it possible that we're just unlucky and they're really telling the truth? And that is up for you. That is your decision. And I do want you to pause this video, and I do want you to make that decision. And I want you to think, is 30 enough? Is 60 enough? Is 90 enough? How many times do you think? Do you think the greater times that we would roll this dice, do you think it would be greater to that 17%? Or do you think it would still be around 10% or 7%? And so that's something I want you to ponder, and I want you to write down your thoughts. Okay, so now we have an application problem. Now, sometimes in our stats videos, your application will be your homework. You'll do these problems on your own and submit them. But for day 1 or day 2, we're going to do these together. And so I know it seems like a lot. If you want to pause it and kind of write this down on a paper, or you could print these from home too. But so here we go. You are to identify the individuals and the variables in this data set, okay? And then we're going to classify each variable as categorical or quantitative. All right, so let's first take care of the individuals. So individuals are like the people in class for this example. And if we back it up just a second, it says on the first day of a stats course, the instructor gives 40 students in class a survey. The table below is the first 4 students on the roster. All right, so the individuals are just those 4 people that are in class. Now, the variables are the gender, the class, the GPA, the pulse rate, all the way down. All of those columns are the variables. So let's write down gender, class, all the way to smartphone. All right, perfect. So now each individual variable, we have to decide, is that variable categorical or quantitative? So let's go ahead and take a look at gender. Gender, you're either male or female. That can be put into a category, that is categorical. Same thing for a class, freshman, junior, senior, that is categorical. GPA is going to be quantitative. Pulse rate, quantitative. Dominant hand, that's categorical. Children in the family, definitely quantitative. Now, homework is tricky. I know you see it and you look at numbers and right away you're like, quantitative, but it's different. And let me explain why. This is an interval. Oops, sorry guys. I just messed that up. There we go. All right, so, and I did it again. Okay, there. This is, no, there we go. Okay, sorry about that. Glitch, blooper. Now it's definitely my bad. Sorry. Okay, anyways, so 0 to 14, that is an interval. Right? So this individual, this female here, her homework, she ranges anywhere between 0 and 14. So that would be a category. This was 15 through 29. So always kind of look at that just a little bit more closely. Sleep, the number of hours is asking, so that is quantitative. And then have a smartphone, yes or no, that is categorical. Whew. Okay. We have one more to go, one more example. Okay. All right. So for number 2, here is the age of all 40 students in that class. So what you're going to do is you're going to summarize the age distribution with a frequency table and a relative frequency table. Now we don't have to do them both separate. We can just do them all into one table, and I'll show you what that looks like. Okay, so I am going to draw a table like this. And let's do 3 rows because we have age, we have the frequency, and we have the relative frequency. Good. All right. So now we have to think of what is the youngest age in this particular stats class. And if you kind of look through all of those numbers, it looks like the youngest age is 14. So we have 14, we have 15, we have 16-year-olds, we have 17-year-olds, we have 18-year-olds. Okay, and then that's it. So now we have to physically count, right? Frequency is that how many, so count how many 14-year-olds are in that class. So you just kind of try to find all the 14-year-olds, 1, 2, 3, and there happens to be 5 total. And so that is, and what helps is if you want to tally them up, as you're counting through, you tally them and then give the actual number. Okay, how many 15-year-olds are there? So there are 4 15-year-olds. 16-year-olds, there's actually 9. 17-year-olds, so weird. There's actually 17 of them. So cool. So we have 5, 10, 15, 16, 17, so there are 17 total. And then how many 18-year-olds there are in the class? There are 5, so 5 18-year-olds. Now, whenever you're doing this, it's just always really smart to add up all the numbers and make sure that you get back to 40, which is how many students are in the class. Okay, so the relative frequency is the proportion or the percent. So now if we think about it, this is 5 out of 40 students, right? 4 out of 40 students, 9 out of 40 students, 17 out of 40 students, and then 5 out of 40 students. So you would just simply type those into the calculator, and you could even give it by, you can give it by the percent or the decimal. You're going to see relative frequency a lot of times written as the decimal, so this would be 0.125, and then 4 divided by 40 is 10%, or 0.10. 0.225, doesn't matter if you put the 0 in front like I did on the first one or not, that doesn't matter. 0.425, and then the last one is 5 out of 40 is 0.125. All right, that's it for today. You have no homework. Thank you so much for watching. Please let me know if you've got any questions at all, and zoom in to our class as well if you have any questions, and I hope you enjoy the rest of your day.